you get to shape your path. You get to do what you want to do. If you're curious, if you are excited and want to try things and want to learn things, things will fall into place and you will figure it out. And that is not to say that I haven't had setbacks or failures. It's just about how you look at it. And it's about getting back up and keeping going.
What's up, everyone? Welcome to another episode of The Artists of Data Science. Be sure to follow the show on Instagram at The Artists of Data Science and on Twitter at Artists of Data. I'll be sharing awesome tips and wisdom on data science as well as clips from the show. Join the free open mastermind Slack channel by going to bit.ly.com/Artists of Data Science, where I'll keep you updated on bi-weekly open office hours that I'll be hosting for the community. I'm your host, Harpreet Sahota. Let's ride this beat out into another awesome episode. And don't forget to subscribe, rate, and review the show. Our guest today is a physicist and data scientist who loves delving deep into data to learn insights that may be hidden by noise. She's earned a bachelor's in physics and mathematics from Trinity University and has gone on to earn a PhD in physics, specializing in nuclear science and quantum chromodynamics from the University of California, Davis. She currently leads a team of 5 doctoral and postdoctoral physicists studying a new plasma phase of matter and the elusive nuclear effects in high-energy proton and nucleus collisions at the Large Hadron Collider at Cern in Geneva, Switzerland. She's got a knack for thoughtful feature engineering to extract maximum value from data while simultaneously reducing the data significantly. She also emphasizes avoiding overfitting, identifying systematic bias, and validating all results. Her favorite part of data science? It's all of it. And she enjoys end-to-end project oversight, everything from designing and developing to testing and productionizing statistical data analysis pipelines. So please help me in welcoming our guest today, a woman who is excited by decision intelligent data science, Dr. Santona Tuli. Dr. Tuli, thank you so much for taking time out of your schedule to be here today. I really, really appreciate you coming onto the show.
It's an absolute pleasure to be here. Thank you for having me.
Talk to me a bit about your path into data science. What sparked your interest? Where did you start? How did you get to where you are today?
Yeah, absolutely. So I was on a path to studying the fundamentals of our universe, but it turned out that I was also on a path to data science. So since a lot of physics is trying to explain phenomena that we observe, it involves making a lot of observations, right? So that's collecting data and then identifying patterns in the data. And that's the analysis aspect. So by doing physics with massive data sets from particle collisions, which we will go into, I have been doing data science for the last several years. And it's been a lot of fun.
Okay, so I got to ask, what the heck is quantum chromodynamics?
So it's the theory of the strong nuclear force. So there are 4 fundamental forces in nature, and one of them is nuclear physics. So just like gravity and electromagnetism, the strong nuclear force is another force, and it acts at very, very short scales, like inside a proton. So quantum chromodynamics is the model, if you will, the theory that describes the behavior of this force.
That is very, very interesting, very fascinating stuff. How does all this tie into data science? How do you see data science affecting the study of nuclear forces in, the next 2 to 5 years? So
our field of data science has been around since before data science was kind of hot, right? So we've had these mysteries in particle and nuclear physics trying to understand why the universe is as it is. And we built these large particle accelerators and detectors, and they produce massive amounts of data. So without very clever data science, there's no way we could be looking into that data and coming up with the answers to these questions. It plays in as we go through and as we evolve our techniques and we borrow from what other practitioners are practicing around the world, we can only get better at going through that data and answering those fundamental physics questions.
So what do you think is going to be the next big thing in data science in the next 2 to 5 years?
That's a really tough one. So I can think of sort of three ways of responding to that. So in terms of technology, I think NLP, natural language processing, and like semantic understanding graphs and using machine learning is booming. And so we're sort of in a similar way to how computer vision was booming maybe 5-ish years ago. So in terms of like field of data science, that's where my thought goes. In terms of the big picture, in tech, that's going to be the next big thing, I think, is going to be empathy, particularly for data science. Ethics, making sure we mitigate all of our biases, that's going to be a very, very important thing going forward. So there have been more and more discussions recently about thinking through data science projects holistically and not just as a chain of discrete engineering tasks. And so when you think about things holistically, you're better able to think about their impact, the impact that they're going to have on real people on this planet. And then third, and finally, in terms of applications, I am really excited about data science in ag tech and sustainability. Of course, there have been lots of advancements in healthcare, which has been wonderful to follow, and in ed tech, another field where there's a lot of ongoing work, especially with NLP. Like we have a lot of text documents that can be used to make education better and more accessible. So those are very, very interesting as well. Data science applications are often about increasing efficiency by teasing out more value from current systems, like systems that are already in place. We apply data science, supplement these systems with insights from data and make them more efficient. And there is huge potential to do this in the space of agriculture globally, I think. So that's the thing that I'm most looking forward to.
So we talked about some of the positive applications of data science in the next 2 to 5 years. You mentioned a few right there, but what do you think would be the scariest applications of data science and machine learning in the next 2 to 5 years?
I'm going to answer that by sort of weaving together my previous two answers. So data science will have a positive impact in the immediate future by not having negative impacts. So by becoming more introspective, data science applications can have a ton of positive impact everywhere. As I said, all of these different fields. So we've seen examples of machine learning and AI that try to mimic a sort of human behavior from data by learning from data. And in that, they have amplified some of our isms, right? So we've seen those things happen. And that's sort of one of the worst things that can happen is the AI or the machine learning algorithm sort of learns our worst aspects of us as society and then somehow magnifies that. So in my mind, that's the scariest timeline, right? That if we collectively fail to be responsible and conscientious human beings. And so by being cognizant of that, by being empathetic and ethical, I think we can definitely avoid that. And you'll notice that I'm talking about us humans as data scientists, not about, AI. I'm not scared of the artificial AI overlords. I'm scared about how we approach this field.
What can we start doing today to become more empathetic, more conscientious data scientists?
Introspection, just in very general terms. Every project that we work on, just thinking through where the data is coming from, why the data looks as it does. And so identifying our biases, starting from the data collection level. Like, this problem that I'm trying to solve, I have to be able to solve it for everyone, let's say, in a certain, for the product market fit, there is a certain subset that I'm targeting. But at the same time, within that population, I shouldn't discriminate in any way. So thinking about where my training data is coming from and why it looks the way it does, balancing classes if that's something that needs to be done, going out of our way to get more balanced and less biased data. Starting from there, and then just throughout the entire process, really thinking through, asking ourselves the question, why are we making this choice? Does it make sense? Is it going to have positive impact? If not, rethink.
So you may have covered this in your response right now, but I'm curious, what you think will separate the great data scientists from the good ones in this vision of the future that you have?
We often think of greatness in terms of success metrics. Like, if you've gotten 5 promotions in the last 5 years, then you're a great data scientist. But in order to separate truly great data scientists, we have to think about what they're doing, the actions, and their willingness to say no when asked to work on something, that doesn't jive with their values and views. So yes, I think the way I'm framing things, it's a whole. We have to think about it holistically, and we have to sort of be introspective and look forward. And by doing those things, not only can we benefit society, but we can also set ourselves apart as great scientists or great data scientists.
Absolutely love that response, because I 100% agree with that as well. We need to be more thoughtful about the way we're doing our work and the implications that we'll have downstream, even if you don't think that your end result, whatever product is that you're building, is actually going to have an effect. You should still consider the effects that it has. Really interested to get into your work that you're doing at Cern. First, tell us, what is Cern?
So Cern stands for the European Organization for Nuclear Research. It's a weird acronym, I know, because it's an acronym from the French term. And this is a huge research complex. You can sort of think of it as a parallel to NASA, only to the extent that it is a huge research lab facility that is focused on one sector of physics. So like NASA is interested in the space and sending astronauts out, we at Cern are interested in going sort of inward and going to the smallest scales and figuring out what fundamentally things are made of. We have a Large Hadron Collider. It's called the Large Hadron Collider. It is a circular particle accelerator. It is 27 kilometers in circumference. So it's very, very large. And there are, towns that live on top of this. So the accelerator ring is underground, about roughly 100 meters underground on average. It straddles France and Switzerland. So there are, Swiss towns and French towns just like above ground, and people have no idea that this thing is underneath them in some cases. But so what we do is we accelerate particles, use this massive ring in order to keep adding speed to little particles. And until they get to very high energies, that's when we collide them, hence collider. And then we study the product of those collisions. So we try to take a snapshot of the collision by building particle detectors around the collision point. So those constitute of hundreds of millions of sensors. Very simple sensors in the sense that, it's like a bit reading out, right? Whether there was something that the sensor picked up or not. When you have hundreds of millions of those, you can put different signals and different sensor readings out in order to get deeper knowledge about what was actually happening in that collision. So that's what we try to do. We try to capture what happened and then analyze that data downstream and really figure out why particles interact the way they do, why forces interact with each other, or forces are applied in the way that they are.
So speaking of particles, while I was doing my research for you, I came across this concept, or this Y particle. What is this Y particle?
The upsilon particle, it's called the upsilon. And so the Greek symbol for that looks like a Y. So we often just write Y. So this upsilon particle is a meson, which means something to physicists, but it's a particle that's made up of two quarks that are oppositely charged. And more specifically, it's a quark and an anti-quark. So quarks are fundamental particles. If you go inside a proton, which we don't really think of going inside a proton because, it's like a elementary particle, and it makes up the nucleus along with neutrons, makes up an atom. Atom's the building block. So that's sort of how we learn about how things are made of. But if you actually look inside a proton, you'll find that also has building blocks, and those are quarks. So there are a few different types of quarks, and they have interesting names. There's top and bottom and charm and strange. So the upsilon particle is made up of a bottom quark and an anti-bottom quark. And it's a very heavy particle. So it doesn't exist normally. It's only created in these very high energy collisions. And we try to really leverage that in order to see how this particle behaves and what it can tell us about, the early universe.
Are you an aspiring data scientist struggling to break into the field? Well, then check out dsdj.co/artists to reserve your spot for a free informational webinar on how you can break into the field. That's going to be filled with amazing tips that are specifically designed to help you land your first job. Check it out. dsdj.co/artists. That's super fascinating. What do all of these things have to do with data science and machine learning? Like, talk to us a bit about how you're applying it to solve these type of problems. Like, what type of problems are you solving? How are you using data science to make progress against them? What's your workflow like in this space? How do you go from data to decisions?
Yeah, absolutely. So we collect these particles and we have all this data, right? So we sort of covered that. The data is readouts from these sensors, and in real time, when the particle collisions are happening, we're actually generating petabytes of data per second. So that is a lot. We're, of course, not able to store that, all of that, or even process it in real time. We have, bandwidth limitations about how much data we can siphon off. So a lot of data science, more on the data engineering side, sort of goes into building out the filtering algorithms that are going to decide what to siphon off and filter on in real time from these collisions. And a simple example, in one particular collision event, we might get thousands of ordinary particles, let's say electrons, being created. Now, that's not a super interesting event because we see electrons every day. That's not what we're after, right? Remember, the upsilon particle is, in my case, my team, that's what we're after. So what we try to do is figure out what sort of signature an upsilon particle will leave behind and use that to filter on this massive data so that we're only keeping the events where the upsilon particle may have been created. Now, one of the cool things about this field, or the physics applications of data science, is that we never have labeled data, right? So it's kind of, we have huge data, but none of it is ever labeled because the whole idea is we're trying to figure out what was created and, what's going on. We have to have a very thorough understanding of both the physics of what we're looking at, but also the data. So in terms of what is my capability with my sensors, with my particle detector, what am I going to pick up? What am I going to leave out? How do I compensate for what I'm not able to collect, what data I'm not? So really thinking through like how the data is biased in the first place and working to compensate and correct for those effects. So to me, that's one of the interesting bits. And then so starting with building these algorithms to collect the data all the way through. So we reduce the data still, even after we filtered on the right data, like there's, as a data scientist, you'll know that the signal and noise still have to be sort of separated. And there are going to be regions where the signal is the signal to noise ratio is greater. And there can be selection cuts that we can make to really leverage that. So all of that is one aspect to me. I really enjoy the feature engineering aspect, actually, personally. Like ML modeling is fun and sort of the end product is fun as well. But feeding what you feed into the machine learning model, of course, is extremely important. And so spending that time feature engineering, really looking at my data, thinking about the physics behind it, thinking about my constraints, and finding the best features that are going to be useful to me, and like putting different features together to make better features and so on and so forth. So that's actually, I would say, probably 60 to 70% of what I do on one of these projects. And then ML models. So for machine learning at Cern, we typically tend to use simple models, more like what is called traditional machine learning. So a lot of regression, classification, clustering. More recently, we have had efforts to look into like deep learning techniques for the same sorts of analyses. But again, the fact that our data isn't labeled throws in a wrench. And then the other thing is that we tend to only say we have seen something when we're absolutely sure we've seen it. So you may have heard of the 5 sigma rule in particle physics. So it's only when we have very high statistical confidence that we're going to go ahead and actually say that, okay, we've seen the Higgs boson or this this particle or that particle. So that's another reason thinking through the machine learning algorithm and having it be very explainable is important to us. So a lot of thought goes into the machine learning models as well, and we try to err on the side of simple rather than complicated, and then processing whatever is spit out. Again, like just like you can't provide any data into a machine learning model, like you have to put forethought into how you're going to shape the data. On the other end as well, when something is spit out by the ML model, that doesn't mean anything, right? You have to transform that into an actual indicator that means something and that other stakeholders are going to care about. So that's the other end of the process. And as you said in my intro, I really enjoy, the whole end-to-end process and every part of it.
That's so fascinating and so awesome. Like, you can really hear your passion for the subject as you're describing everything. I'd really love to dig a little bit deeper into this. So it's pretty interesting, right? Because, typically when we're working, and let's say we're doing a fraud detection type of problem, we have the situation where we're trying to upsample the class that's not as frequent, but you're in a situation where you have to kind of downsample the noise in a sense. So it's kind of like the reverse problem. Is that what you mean by data reduction? Like, could you talk to us about what data reduction is? How important is it in the work you're doing? Maybe touch on, some bottlenecks that you're facing.
Yeah, you're absolutely right. It is, sort of the reverse in some sense of that problem. We are not really able to amplify the signal just because we have to sort of, a lot of the times, the item that we want to report is how much of a particle was created. And if we upsample the production of the particle, that sort of brings it into question, like, we didn't actually see this. So why are we sort of basing our ML models on this upsampling? So yes, you're absolutely right. What we instead have to do is prune the noise away. A lot of the times, some of the techniques that have worked well, at least with my analysis, is looking at the feature space in its entirety and looking at and placing various selection cuts and really seeing what effects they have, moving around the selection cuts and seeing what it does to the signal class and the noise class, and sort of optimizing those selection cuts. And also the other aspect of that is rules-based clustering is also something that I use a lot, just because I know something about how this particle should behave, and again, what my detector is like. I'm able to set certain rules about, okay, if you see this criteria being checked off, then you can probably classify it as this upsilon particle or this other particle. So those are some of the techniques. And yes, so because the data is big, so in my particular, this last analysis that I've been leading, we're just about to put the results out. In the end, I was able to extract about 5,000 upsilon particles. But the data that I started with was tens of terabytes. Right. So it's really, we have to identify the events where this particle is produced, and then from the thousands of particles created in that event, I have to identify that the upsilon was created. So it's really, really interesting work. And again, we try to use really simple techniques whenever we can. And really what I mean when I say simple is explainable. Like, does this make sense? Is this something I can defend and explain to someone else? And they will be convinced that, yes, this choice makes sense. So that's been the secret to dealing with various data bottlenecks and data reduction problems.
Isn't that beautiful? Even when trying to explain what makes up the universe, parsimonious models are the best. Questions based on what you're saying here, just kind of for definitions. What do you mean by selection cut? And can you also kind of maybe, name drop a couple of these rule-based clustering algorithms that you're using so that, our audience can go look this stuff up on their own time? Sure.
So our data is event data, because the collision events are separately we're able to take a picture of a single collision event, which is really cool. And the other descriptor that we use is sensor data, because yes, we are getting these readings out from the sensors. So using what my sensors are reading out per event, I can reconstruct. So it's sort of like back propagating. I can reconstruct what was happening in the collisions to some extent and with some degree of confidence, right? So I will say, let's say that I saw an electron in these few sensors that tell me together that when I combine that information together, it tells me that this electron was traveling in such and such a direction, let's say, upwards, and north and whatnot. So that's one point of information. And then from a different set of sensors, I'll be able to say, that was an electron because it was a negatively charged particle. And I think it had this momentum or this mass. So all of these things. So a lot of cool stuff goes on really at that hardware software interaction level, and really reconstructing back to what happened in these collisions, which to me is always really interesting, because we're trying to look back and answer questions, right? A lot of physics is like cosmology or early universe physics is, okay, what happened? How did the Big Bang happen? What happened after that? And so on and so forth. So this looking back is sort of very, very ingrained into physicists, the way physicists think. So I really think it's super cool that we're able to have this data and be able to really answer the questions of, what was going on that created this data? And a lot of data science problems are the same, right? I mean, we try to build predictive models in certain spaces, and that's really useful as well. But a lot of the time, the way we achieve that is by looking at the data we have today and thinking back or looking back and discovering what caused that data to exist in that way. And based on that, we do the predictive, the algorithms to figure out what's going to happen next based on the data we're getting today. So that's just something I wanted to mention. I think it's really cool. And then when I look into this feature space, right, I have once I've processed the sensor data, what I have is reconstructed particles and various attributes that these particles had. Again, going back, the direction in which it was going, the charge it carried, its mass, its momentum, sort of all of these different attributes. So that's my feature space, essentially. I mean, there's a lot of other metadata as well, like, what was the energy in this collision? How head-on did the collision, how head-on was the collision? So you can, if you imagine accelerating two, or like just throwing two tennis balls at each other, right? They can either be completely head on and jump off, or they can scrape, and so on and so forth. So that becomes an interesting aspect of this problem as well. So I have all of this data. My goal is to sieve through these data and find my upsilon particles. So it's like finding a needle in a haystack in terms of how much data I have available and how rare my signal is. What I do a lot of the time in terms of the selection cuts is I will look at these various attributes of different particles, and I will see where I can draw my analysis box. I don't want to swim in this massive amount of data and just, go move around in a random walk until I hit an upsilon. What I want to do is systematically, strategically figure out what my most effective analysis box is going to be, where my upsilons are hiding in which area of the feature space. So I'll put selection cuts on, let's say, I have muon. That a muon is a heavier electron, essentially, that I've reconstructed, and I'm able to pair it with another muon, and say that, okay, this two muons probably came from an upsilon. So what I'll do is I'll play around with the momentum range, the mass range or something like that, until I see that there are other ways. So there are ways in which I can classify my upsilon, right? The rules-based clustering that I talked about a little bit. So basically, I'll say if these checkboxes are checked, then it's an upsilon. So I'll hold those attributes constant, and then pick one attribute that I'm going to play around with, that I'm going to sort of change my value, the cut that I'm going to place in order to define this box. It's like a knob. It's like turning a knob. I'm going to move it around and see, well, statistically speaking, how does turning this knob affect whether I'm identifying this particle or this event as having produced an upsilon, as opposed to just other things that might look like an upsilon in certain ways or just be noise. So that's what I really mean when I say selection cuts. It's fine-tuning the whole space of my analysis so that I'm not just randomly looking.
That's really, really interesting. And just like you, like feature engineering is also my favorite part of the process. I was wondering if you can maybe share some tips with our audience so that we can be more thoughtful in our feature engineering. And maybe if you were able to provide us like an example of how you're doing feature engineering in your work.
So the way I approach it is that I know very little and I want to learn from the data. Of course, there are assumptions that I do go in with. So if it's a particle physics problem, I do bring in my domain knowledge. If it's an NLP problem, then I do know something about how, languages interact. But when I look at a particular data set, I try to learn as much as I can from the data, first and foremost, even before I start thinking about, what my features are going to be and what my ML algorithm is going to be. So for me, this includes slicing and dicing the data, looking at lots of plots of different variables against each other, looking at their correlations, and so on and so forth. Even studying why certain features might have null values and why others don't, and how to sort of interact with that. So that's sort of where I begin. And then as I learn more from the data, I'm able to say, okay, this is a feature that makes sense for my ultimate goal, right? So that's the other aspect of it, is I should always have in mind from the beginning what I want at the end. So that's also part of the holistic sort of decision process, is knowing, not trying to manipulate the data in order to get a result that I want, but knowing what I want to test, knowing what a positive result would be and what a negative result would be and what a null result would be. And that's when I start thinking about the features in context of that, like really which of these features or what combination of these features is really going to add value to that fundamental question that I'm going to answer at the end. Just at a high level, these are the ways in which I approach feature engineering and why I enjoy it so much, because I feel like it's where you get to be the most creative. You get to exercise those muscles more the most, because ML algorithms, yes, you can there are pros and cons to different ones, and you can definitely that's also fun, sort of figuring out which is the best fit and so on and so forth. But the math is sort of fixed, right? You get to play with knobs, but you don't really rewrite any fundamental ML algorithm when you apply it. You're just fit, predict. But so the really creative part of the process to me is figuring out what features are going to help me. So that's how I tend to think of that.
Absolutely agree with you. Like feature engineering, I think you're only really limited by your own creativity. How do you view data science? Do you view it as an art or a science?
Both. Definitely both. So the science versus arts divide often boils down to procedural versus creative processes. So like a science is sort of regarded as, you take step one, then you do step two, and so on and so forth. So it's very procedural. Whereas with art, you can be, sort of more creative and randomly sort of swing your paintbrush around. But of course, there is plenty of creativity in science and plenty of procedure in art as well. So it's not really a fair divide, right? Because you can be as creative as you want with science, and even in art, you have to. Well, if you're trying to paint a picture of, let's say you're drawing a portrait, there are rules about how you go about doing that. You can't just start, arbitrarily. So yeah, for me, it's very, very much a mix of both art and science. I mean, it's called data science because there are certain scientific techniques that we often use. It borrows heavily from decision science, from statistics, which is math and science. So there is definitely that aspect of that. But the thing that we just talked about, right, with feature engineering and being able to imagine how the data is going to tell a story, not wrangling it into telling a story that you have pre-planned in your head, but really showing the creativity in bringing different pieces of the data together to tell its story. I think that's a very creative process.
How does the creative process come to life in data science?
So for me, the creative process is thinking outside of predefined paths. So being able to step back from approaches that are known to work and to come up with approaches that haven't necessarily been tried before, but that could work. And then it would be so cool if they did work, right? This process that you just thought of, this approach that you just thought of. So, trying to apply that to your specific data science project and just seeing it through, like whether maybe it doesn't work out quite the way you thought it might, but just being able to step outside and think of alternative approaches, stepping outside the predefined paths. To me, that's how the creative part of my brain is really engaged when I'm doing data science. And the other aspect of that is in science in general, we do a lot of jumping around and thinking about different approaches and trying to pull them together, right? So we're trained in how. So this is a little bit redundant. Like it's just emphasizing the same point that I made earlier. But so we're trained since we're little on the history of how knowledge has evolved and how people have thought about things and why certain ideas were good and why certain ideas failed, right? When you're problem solving, it's about you. You're the one who is thinking through this problem. You have these guidelines based on what you've learned and what you've seen other people do. But in the end, the canvas is yours. So you get to have as much of a creative impact on this particular project as you want.
What's up, artists? Be sure to join the free open mastermind Slack community by going to bit.ly.com/artists of data science. It's a great environment for us to talk all things data science, to learn together, to grow together. And I'll also keep you updated on the open bi-weekly office hours that I'll be hosting for our community. Check out the show on Instagram at the Artists of Data Science. Follow us on Twitter at Artists of Data. Look forward to seeing you all there. You were featured in an IMAX movie, the first movie star I've had on my show. Tell us about this. Tell us about this movie that you're a part of.
It was such an amazing experience. So the vision of the film was to depict scientists doing science. Real scientists doing real science. So my PhD advisor was asked to be on the advisory board of this film, funded by, amongst other sources, by the National Science Foundation, and at this point, many, many other, so Cern, the LIGO experiment, the Perimeter Institute, UC Davis, and various other educational institutions sort of rallied together the funds. One of the advisors was my PI. And as the team started to develop the narrative, the creators of the film got increasingly excited about the idea of having the atom, so the fundamental particle, the atom, to be the protagonist, which is a really interesting approach, right? You don't have a person as a protagonist. You really want to study the journey of this atom. And so that's where it began. We went to, so once they figured out exactly what our research group works on, they were like, yes, this is what we want to follow. So it's me and my couple of my team members, and then a couple of the other people from my research group as well. We all spend time at Cern while the data is being collected. It's very much a team effort, very collaborative. We're all there, staying up late together. I mean, not year round, but when our collisions are happening, it's a very hands-on and, all hands on deck kind of process. So they were like, that's perfect. We want to be there and just film you as you're doing this work. When making a film, you have to make some adjustments. Like they put these lights sort of on top of our computers so that our faces would be lit up and all of that. But at the end of the day, they were just filming us as we worked. So all of the excitement that shows up on our face, the curiosity, all of that is authentic and real. And that was extremely rewarding for us to be a part of. And then they interviewed us. So we did the whole green screen kind of talking about our our journeys, and how we made it to Cern, and what we're really hoping to answer. That was one aspect of it. And then at the end of the data taking period, when we were shutting down the experiment, we always go to a bar and just hang out and celebrate. So they wanted to follow us there as well. So there are some shots that were just like, yeah, this went really well, and we're just drinking and saying that. And so it's very, very cool. And the whole objective, as I look back on it now, picking the atom as the protagonist, following us as we collected data at CERN, all of that really feeds into the eventual goal of this film and this project, which is the audience should be able to look up at the screen and see themselves reflected in it, being able to understand that the physics that's going on, it's not about going into the depths of the physics. Of course, we don't do that in this film, but just to understand that physics is very much within their reach. Science is very much within their reach. I hope that the audience will see me and think, oh yeah, I mean, there's nothing special about that girl. She's just, has this background and is doing this really cool stuff. So I can too.
That IMAX movie is called Secrets of the Universe. And when does that get released, or is it already released?
Yeah, it's called Secrets of the Universe. So it has premiered at the Smithsonian in DC. We all got to go to that red carpet screening, and that happened last summer. And since then, we were actually supposed to have another red carpet screening here in California in April, but it got canceled because of COVID. But very soon, I mean, when things get back to normal, we'll have that second screening.
I'm looking forward to it. Hopefully I'll get a chance to watch that out here. I heard you speak about this a little bit earlier about the need for interpretable models. I saw a really well-written post from you on LinkedIn around interpretable and explainable machine learning and how they're different. Would you mind speaking to that point?
Yes, this is something I've been thinking about a lot recently. So to me, the distinction is an explainable machine learning model can be explained before the fact, and an interpretable machine learning model can be interpreted after the fact. So let me dive a little bit deeper into that. When I am building a model to extract some particle physics phenomenon, for some nuclear physics phenomenon, because of things we've already talked about, it's very important that I can explain my choice. We have so many levels of reviews within our collaboration because we really don't want to make any claims that we can't take back. So, by contrast, like in industry, of course, it's more it's driven a lot of the times by bottom line, like the actual revenue, right? So if you do something wrong, yeah, it's terrible. You might have lost, millions or billions of dollars or whatever, but you can sort of learn from that and really change your approach and hopefully make up for that. In our field, it's of course still true. We're learning about something, so we don't. It's not like we can't ever say that, oh yeah, we were wrong. So you scientists go back all the time. But even with that being true, we really have a lot of apparatus in place to make sure that we really understand the things that we're claiming. So that's why the explainable part is really important to us. So even before I've fit my model to data, I have a good sense of what the different parameters are going to represent, why I'm setting my certain hyperparameters to certain values, and so on and so forth. The other end of it is I apply my machine learning model to data, and I get some results. Maybe it's a classification if I have my the records classified, and then I can also look at the importance of the various features, right? So which features played a part in this decision, which were most important, which were least important, and being able to look at that and understand why certain features ended up being important in this decision. Even if when we started, we didn't really know why it might be, to be able to interpret that and understand that to me is interpretable machine learning. That's the way that I see it. Now, Of course, they're not exclusive. These two things are not exclusive. And they also don't, like, one doesn't imply the other. So just because starting out I have a explainable model doesn't mean that at the end I'll be able to interpret my results necessarily. Similarly, the other ways, oftentimes when I talk about explainable machine learning, people will sort of think that I'm saying interpretable and think that I'm making a statement about why traditional machine learning is better than deep learning, but that's not the point at all. Deep learning can be highly interpretable. You may not be able to explain exactly why or exactly how something is going to, some deep learning algorithm is going to work ahead of time based on your data, but afterwards you may be able to interpret the heck out of it, right? So they're really not the same thing. They don't imply each other, and they can simultaneously be true or untrue.
And another thing you've been thinking about is decision science. Can you share your thoughts around that? First, can you maybe help us understand the distinction between decision science, data science, and what have you been thinking about?
To me, data science is a part of decision science, but decision science is in some sense bigger. Like it's more of an umbrella, and data science fits underneath that umbrella. One of the ways we can distinguish those two is quantitative and qualitative aspects. So actually, it's not a distinction. It's more that data science tends to be more quantitative by definition, by nature. Decision science comprises both that quantitative part and a qualitative approach where you're making value judgments. You are, as a decision maker, you are thinking through things and not just relying on data. You have to be able to interpret what the data is telling you, and based on that, you make decisions. In some sense, calling it qualitative isn't even that fair, because there's so much, science that goes into making good decisions, right? So again, like, these are all very fluid. Science and art are so fluid. So as a decision scientist, you have to check so many different sources of bias. And that's why I've been reading up and learning a lot about decision science recently, because, again, feeding into what we started this conversation with, mitigating our biases, being able to make sure that our decisions and our processes have positive impact going forward. It's a picture that you can only paint once you have all of these pieces in place. When you're making a decision, the part from data science that you tend to rely the most on is sort of the statistical significance. So you have done some analysis on data, and you're claiming to have seen some phenomenon with certain confidence level. And that's very important to the decision scientist, right? Okay, not only what you're claiming to have seen, but also the confidence you have in this claim. And that's going to factor into the decision scientist's outlook on this particular decision. And only when they incorporate that in with their sort of decision framework, and having thought through all the different biases, like, confirmation bias, et cetera, that they could have, and once they sort of put everything together, are they able to make good decisions? So what we can do as data scientists, even if we're not making, big decisions, even if we're not the ultimate decision maker on a certain project, what we can be doing, how we can be getting better at data science, is by incorporating some decision science into our work. The way we can do that is by thinking about the whole data science project end to end. When we start, we have to think about the end goal, and we have to like put ourselves in the decision maker's shoes and test all of our assumptions. Does it make sense that I'm assuming this about the data when this is the thing I want to decide using the data? Like, am I making a fallacy and making this assumption? Am I, twisting my results at the very beginning? Because it can't just be about numbers. I can't just, give someone like, okay, yeah, this is what I'm seeing, X percent, Y percent, and they go and make this. I have to be a conscientious person as well and think about what that number means. So thinking through that process is, to me, the best way the marriage between data and decision science can happen. And the other aspect of this is that if these two individuals or these two roles are completely separate, data science and decision science, there's no back and forth, and there's no collaboration. There's no iteration of the process. So you might be working with a decision maker consistently year after year, but if you don't have a back and forth, you'll be making the same mistakes you've been making, right? So the data scientist has to have a way to speak to the decision, and the decision scientists has to be able to sort of look at the data to inform their not just like the final result of the data, but the data in its entirety. So that marriage, I think, is extremely important. Both sides should be able to talk to each other, collaborate with each other, and iterate on the process to get to better processes and better understanding from data.
Kind of switch gears here now and try to pick your brain on another couple of things. For the people out there who are trying to break into data science, and maybe they feel like they don't belong, or they don't know enough, or they don't feel like they're smart enough, or they're just intimidated by everything you have to learn. Do you have any words of encouragement for those people?
Yeah, I'd say the same thing I say to anyone who's trying to break into anything new and lacks confidence, which is that I genuinely believe that it's not a capability thing, that it's never a capability thing. If you want to do data science or tech or coding or learn a new language, you absolutely can. There are some skills that you'll need to pick up, but we're used to that. We have been learning new skills every day since birth. And beyond that, what else would you need, especially to break into data science? You need to meet other data scientists. You need to observe how they think, what they do, how they interact with each other. And to me, that's the real skill set. Earlier this year, I started thinking about product management in addition to data science, because I like sort of taking holistic approaches to things and really sort of strategizing from the beginning. Interacted with some product managers. I tried to pick their brain, try to get coffee with them and really understand what this field was. And one thing I kept hearing over and over is think like a product manager. Okay, but what does that mean? Now, having spent more time sort of thinking about it and learning from product managers, I understand what that means. And I have the same advice for data scientists. You have to think like a data scientist. And that's not just a Wiseman saying, and that doesn't really have any meaning. It absolutely has meaning. The way you can achieve this is by meeting data scientists, observing them, learning from them, thinking how they think, watching how they speak. The reason I say that is it's not, the speaking may not be an important aspect of being a data scientist, but it definitely gives you insight into what's going on in their head, like the content they put out there on LinkedIn, for example, or various other sources. I think that's one of the best things you can do to pick up this sort of the more nebulous skills around data science, beyond the more harder skills, so to speak.
What does it mean to think like a product manager? I think a lot of our audience would love to hear your take on that.
So I took this sort of short program. It's called She Aspired. So I guess I'm giving them a shout out now because I have the platform. But so this is really cool. I was part of the first cohort, and it was a number of people who wanted to either break into product management or just learn about product management. And what we did in this program is we approached sort of the transition to product management as a product itself. How this helped is it's hard when you talk about things in a nebulous way. Like someone might advise you, okay, you want to be a product manager at XYZ company, go pick a product that they actually have out there and then see, how you can improve it and maybe write up something on that and then, try to sell yourself in that way, which makes a lot of sense, but it's still difficult if you don't know what product management is, right? You can't just go and pick up a product and, tear it apart. But so by having a more tangible product that you're working on, aka your career or your transition, or you can think of your breaking into data science as your product, and then you dismantle that, right? You can sort of really take it apart and think how different parts of it play with each other. Like, so we were just talking about the skills that you need to break into data science, right? To get that data scientist job. So being able to separate or distinguish what the end goal is, and the steps that you need to take in order to get there. So making the roadmap, that's a common term used in product management, setting the key objectives, and then sort of having a timeline for those, or having these check marks about like, when do I say that, okay, this aspect of this project or product is done, and then I can, move on to the next part. So to me, product management is very much, it's very dependent on how you can break apart a bigger project, a bigger idea into small bite-sized chunks, and then you can strategize whether you're going to complete them in series or in parallel. And you have to pull your resources cleverly. If let's say I'm working on something now and I have this resource that helps me do it, and then tomorrow I'll work on something else, and it might require the same resources. If I had noticed this before, I might be able to pull that resource at once and work on these tasks 1 and 2 at the same time. And that would save me a lot of time and make it more efficient. So thinking like a product manager or being a product manager is really about strategizing and figuring out the most efficient ways of approaching a problem or a product, and being able to also have the flexibility to sort of iterate, learn from what you're doing and keep applying that forward. And I truly believe that applies to so much in life as well.
It's very well put. And I think we can all end up being product managers after that. That's a really great explanation. I like what you said, observing data scientists, not necessarily downloading their brain, but absorbing the way they think about things, how they tackle particular projects, particular problems, what vocabulary they use, right? So a lot of it is just developing the right mental models for yourself so that you can apply those mental models in the right scenarios, right?
Mm-hmm.
I think, a lot of data scientists are out there working on projects, and they might feel like a bit of fear or hesitation because they're trying to make the project perfect, right? They don't want to release it until it's perfect, whether that's professional or personal projects that they're working on. Do you have any tips for anyone who is in that type of mindset?
Yeah. Try to get over it. I used to be a perfectionist when I was in college. There's still some aspects of that I carry. I can really get hooked on one thing and sort of spend time on it sometimes. But I've also been actively trying to not do that. So get over this idea that it has to be perfect before I push it out or send it or whatnot. So I would just try to give the same advice that I give myself to anyone else out there who's struggling with this. Just put it out. What's the worst that can happen, right? Maybe someone criticizes it in some way. I'd never be heartbroken about purely negative criticism, purely, like some criticism that isn't meant to help you. But it might turn out that this criticism that you're receiving on it is actually going to help you iterate on that project and make it better. And you would have never gotten that feedback if you didn't actually put it out there. So yeah, just put it out. Ask the people that you'd feel most embarrassed about if they thought that it wasn't good enough. Like you have in your head, right? Like, oh, if this person sees it and then they're going to think that it's not good enough and I'm embarrassed. And so just go and ask them, build that report, talk to them. People love being asked to like do things in the sense of like help you out, to like look over your projects, look over your resumes. And there's so many kind people out there that are genuinely interested in helping you in that way. Build that relationship, they'll take a look at it. Absolutely. And they're not going to be mean about it. They're going to give you that feedback, and all of a sudden you know exactly what you need to do to make exactly that person or that kind of person think that the product is good. So, or the project is good. So it's very much the more you step out of your comfort zone, the bigger your comfort zone will get and the more feedback you'll get on your work, and you can keep iterating on it.
So as someone who's a recovering perfectionist, sometimes when we're working on a project and we're getting some feedback, we're getting some criticism, we might feel down or feel like a failure, and we might want to give up. So what can we do to kind of get over that and get through that feeling?
For me, it's a couple of different things. One is just being able to step away, take a break, take a breather. And that can be long or short, but that really helps me refocus and sort of it puts things into perspective. The thing that you're sort of sweating over, staying up nights and working on, it may actually not be that important. So it sort of helps put things into focus in that way, into perspective. And then the other aspect is just keeping at it, which might seem like intention with the first thing. When you're working on something and you're not fully confident about it, rather than getting disheartened, give yourself some slack, figure out what it is about this that is giving you that anxiety or that stress, what's causing it, and, face it head on, and really dig at it until you are able to beat it, so to speak. So you can always, you can take over any hurdle, as long as, if it has to be a worthwhile hurdle, but once it is, you can definitely do it. Having that confidence in yourself and in your process is very important.
Because the most uncomfortable part about that would be just sitting there with the fear, digging through it, trying to understand what is causing it. On the other side of that, that's where the most growth happens, right? When you're sitting in that uncomfortable phase. Talked a lot about, the technical skills that are needed to be a data scientist. What are some soft skills that you think data scientists are missing?
I'll use the word soft skills as well, because it's often used. But I do want to just quickly say that I think that these are all skills, like as important as any of the quote unquote hard skills. And I would, if it were up to me, I would just rephrase it all as skills. But I know what you mean. So the top ones that come to mind are communication. So I think being able to communicate clearly, it doesn't mean it has to be in, perfect English or in perfect sentences, or that you have to express all of what's in your head in one go. But it does mean that you are comfortable talking about what you're doing with others. And communication is a two-way street. It's not just about talking at someone. It's about giving space, listening, and taking feedback. I think that really, really helps. It helps with a lot of processes, but especially with data science. I think when you think through things, like, we have the rubber duck idea. We have the, talking at the mirror and so on and so forth. It is when you talk out loud, speak with someone about something that you're working on, that you get the, smartest ideas, brightest ideas, or you realize why some approach you're trying isn't great. So that's a huge one for me that relates to the second one directly, which is presentation skills. I think are very important. So yes, gradually honing that skill of expressing yourself and what you're working on, getting some buy-in. Is like one way of putting it is when you're sold on your idea, learning the skill set to sell others on it through presenting. And that has hard and soft aspects to itself as well. Your actual data visualization, your actual slide deck, etc., is a part of it. And also how you present yourself and how you speak about what you've been working on. Those two things are extremely important. Let's see, soft. Yeah. And I mean, I feel a little bit like it's emphasizing the same point again, but triaging is another really important one. Rallying people, building, getting people to buy into your ideas so that you can maybe push it to someone, at the skip level or the C-suite level or something. So like being able to have that engagement and being able to triage people into basically sharing your view with others such that they can actually see it from your point of view is an extremely important skill.
Yeah, definitely. Influencing type of skills, I guess, another way to put that. And I totally agree with you. Like soft skills, like don't really like that name either. I think they're really the hardest skills because these are the skills that nobody can teach you these skills. You have to learn them yourselves. You have to actually learn them for yourselves through experience, but through experimentation and, through self-reflection and trying things that work, seeing what doesn't work. And again, being uncomfortable. I was wondering if you could speak to your experience being a woman in STEM and if you have any advice or words of encouragement for the women in our audience who are breaking into tech or are currently in tech.
The first thing I would say is that I feel you. I know that it's hard. It's always hard to be the only person in a room that is different in some way. But if you don't push through that, then you'll always be the one person in the room. It's only when you're able to overcome those insecurities and make a environment that's more welcoming is where you're going to get that second person in the room and then the third person and so on and so forth. So yeah, I mean, I think there is a general recognition that diversity of all sorts is important and good and ultimately helps everyone's bottom line. There's still some, of course, there's a lot of pushback as well. We have systems that, work in certain ways, but find yourself a network of people who believe in diversity and in encouraging and supporting people of various kinds of minorities, be it gender or race or whatnot. And that network really, that support system, if you're able to build that up, that really helps. Even if in that room you don't have that other woman in tech, if you're connected to women in tech through other organizations or elsewhere, then you can reinforce your beliefs and they will support you through that. So I'm part of a Women in Machine Learning and Data Science. It's a nonprofit organization. We have a strong network of women. Same thing with this product management program that we did. We now have that cohort, that a connection, a community of women who are there to support each other and to help these overcome these barriers that we see across the board. I think that's a big one, and I've done that for myself. Finding that community, those communities. It's not just about one. It's sad that we have to resort to this, but that's definitely an aspect of it. Just a different way of looking at it. I grew up in a family with like lots of encouragement, no distinction ever based on gender. So I never walked into. So I went on to major in physics, right? I mean, first of all, it was a small physics cohort, not too many people going to physics, but like there are even fewer women, of course. In my in grad school, my graduating class, I think we were like 7 out of 35 or something women. So it's those numbers are staggering, and they will exist, further into the future. They're not vanishing tomorrow, but going in, knowing that you're equal to everyone else, you're just as good, if not better. I mean, there are definitely things that can make you, put you apart from other people. Maybe, you can be a woman, let's say, and the smartest one in a physics graduate program. Like that is a very true reality oftentimes. And so just being able to walk into those spaces, having that confidence in yourself, it doesn't matter what you look like, what the population is made of. You have to have confidence and faith in your ability in the thing that you're trying to do, be that data science, tech, physics, whatnot. That's the only thing that matters. The system that's in place does not matter. And we're working every day to try to overcome those barriers anyway. But in the meantime, you have to be confident about yourself and your abilities.
Thank you so much. It's a very, very empowering message. I'm sure our audience is really going to take away a lot from that. Thank you so much. So talk to us about the My Hero Award that you were recently awarded. How do you hope to be a hero for women in STEM?
That is a dream. This award was for a short video that we did. Partly, the goal was to have promotional video for Secrets of the Universe, the IMAX movie. We decided to do it because they wanted the audience to get more than just me in the few shots during the movie, but also like understand my story and my journey. So this video is played before screenings of the movie and will continue to be played when the movie is out more officially, before the screening of the movie, to like set context around who I am in this movie. And so it's really the thing that's meant to frame it. So in this video, and you can look at it, you can find it on the Secrets of the Universe website. There's a character profile on me, and the video is included there. So I just talk about where I come from, my journey into physics, how I went into Cern, what it means, what we're doing there. So it's just a frank conversation about me. And I think because I am a woman and because I'm a person of color, it potentially has even broader reach. So the My Hero Film Festival is a yearly festival, and they try to recognize individuals and groups that are setting an example in some way or another, something that other people can sort of aspire to or be inspired by, and sort of, again, see themselves reflected in that. So they picked it in the sciences category as one of the top submissions, or however you want to put it. So that was really cool. I never expected, as a physicist. Getting to go to Cern was super cool. Getting to be in this IMAX movie was whoa. And then on top of that, this video gets this award. So it's definitely very cool. I'm very, very appreciative of all of this and very happy about it. But at the same time, the goal throughout all of this has been about reaching out to people and showing them that it is very doable. You can do it. If I can do it, you can do it too. And you should definitely be thinking that. I'll share one quick thing as well. I just remembered about this movie. So the second screening that I was at, high school, middle school kids were included in the select audience group. And I happened to be sitting next to this 11-year-old or so. I mean, I didn't ask him how old he was, but, looked about 11. And so at the end of the movie, he just looked up at his, whoever he was with, and he was like, mind blown. And to me, that was such a empowering moment. It's like, this kid is getting inspired by this, getting inspired by the physics, by the people. And so that is extremely rewarding. And I just hope that more people and more women are going to watch this and be like, yep, I'm going to go do that next.
What can we do in the data community? What can men do in particular in the data community to help foster the inclusion of women in STEM, in tech, in data?
I think people are learning to be better allies. There's, of course, a long way to go. It's difficult to have conversations about supporting minorities in tech because it often gets intertwined with ideas of productivity and intelligence and things which is, of course, extremely sad. And it's part of the systemic problem that we have. But, because of the way that these fields have been dominated by a homogenous set of people, there's this idea that anyone else is somehow inferior and doesn't belong to this field. So these conversations are tricky, but the only way that we can move forward is by having them. I mean, a lot of people don't know about the biases that exist around them and how they're propagating them. They don't understand that, standardized tests just as an example, SATs or GREs are systematically discriminating against, women or people of color. These are facts that I think the more we write about these, the more we discuss them, the more awareness we can spread about what exists. And, it's again, a privilege thing. You don't realize what your privilege is, but your life has been set apart from the day you were born from others because of certain factors in your life. So just, being able to spread awareness on that, I think can go a long way. To my male colleagues, I think the one thing I would say is never, ever go in with presumptions about your female colleagues. I think most people will be like, oh yeah, I'd never do that and stuff. But I think a lot of these can exist subconsciously. So just think to yourself, take a moment to think okay, I'm about to review this person, this female colleague's code. Am I thinking something already about what I'm going to see? And if you are, then just stop and, maybe revisit or maybe excuse yourself from doing it if you think that you can have that harmful effect. Reflection is always a very positive thing.
Thank you for that. So last question here before we jump into a lightning round. What's the one thing you want people to learn from your story?
You get to shape your path. You get to do what you want to do. If you're curious, if you are excited and want to try things and want to learn things, things will fall into place and you will figure it out. And that is not to say that I haven't had setbacks or failures. It's just about how you look at it. And it's about getting back up and keeping going.
I love it. Let's jump into a quick lightning round here. What's your data science superpower?
Curiosity.
What would you say is the most fundamental truth of physics that all human beings should understand?
That physics is a model, that it's approximations, that the whole idea is we try to explain why things are happening, but we don't know anything.
So what do you think is the most mysterious aspect of our universe?
I think as a physicist, I have to say dark energy. But personally, I think that it's really cool that we exist, that, this small planet has these right conditions for human life to exist, and we're able to ponder on our own existence. I think that's mind-boggling.
So what's an academic topic outside of data science that you think every data scientist should spend some time researching or studying on?
social behavior, maybe human interactions.
So what's the number one book, fiction, nonfiction, or if you want, you can pick one of each, that you would recommend our audience read? And what was your most impactful takeaway from it?
I think even till date, my favorite book is 1984 by George Orwell. I read it very early and I was very sort of enamored with it. What I do like about Orwell is he has some essays on communicating and writing, and those can also be very, very helpful in figuring out best ways to communicate things. So that's more of an endorsement of an author than a particular book. Most recently, I read a book about or set in World War II Germany, which to me it was a really cool way to observe something that we learn about in history books, but this was it was a narrative, right? So another way of what I'm trying to say is historical fictions based in historical contexts. I really enjoy, and I don't know, maybe others can benefit from that as well. It gives a human touch to something that actually happened and people suffered in, and so on and so forth.
So if we can somehow get a magical telephone that allowed you to contact 18-year-old Santona, what would you tell her?
Keep doing what you're doing. You can do it. So the thing when you look back on what you did like 6 months ago and you're like, oh my gosh, I was so stupid back then. So that happens and that is real. So there are, of course, things that 18-year-old Santona did that I would very much be like, oh my gosh, what? But no, the real thing is that things turned out fine, right? Things turned out well. So just keep doing what you do. And this is the same advice I would have for any 18-year-old is sort of like, have faith in yourself, be curious and learn and do what you do.
What motivates you?
Learning. It's a bit cliche, but I am excited to learn more in different fields. So it's something that, so it ties into curiosity and learning. It's not just about, honing my data science skills or my physics skills or something. It's about learning what other people are thinking about. I think that's really exciting.
So what song do you have on repeat?
I really like Resilient by Raising Appalachia. It has a very strong message. So I listen to it almost every day, especially in times like these. A couple of the lines are, we are resilient, we trust the movement, we negate the chaos, uplift the negatives.
I definitely have to check that out. So how can people connect with you? Where can they find you?
I am available on LinkedIn. That's probably the best way. Just my name, Santona Tuli. That's without an H, although you pronounce it Santona. It's Santona, spelled Santona. So LinkedIn is the best way to reach me. Please connect with me. I love meeting new people.
Dr. Tuli, thank you so much for taking time out of your schedule to be on the show today. I really, really appreciate having you here. And I know there's so much here that our audience is going to learn from. Thank you.
True pleasure. It was so much fun. Thank you.